You love Ruby, and you love Rails. And you wrote an app that is amazing, and everyone thinks you're a genius. And then your customer asks for a change. Just a little bit. It's okay to check out the code, you get your text there. You make one change, and you make another, maybe a couple more. You have to take a few tests, but it's not so bad. You get it all working, you check back in, you deploy it to production. And then they tell you they changed their mind. They weren't quite right, double take review. And you're like, okay. So you get the code, you check it out. You make one change and then another, and then a few more, and then it turns out you have to make a bunch more changes. And this is harder than you thought it might be. It's not really all that much fun, but you do it. You get it fixed, you get everything changed, you make all the tests running, you check it back in, run. And then they ask you for a new feature. And now it's a crisis. Everyone's hair's on fire. They want it tomorrow. And you go look at the code and you find out that it's almost impossible because the code just wasn't designed to do this. And so you just pick up a machete and you pretend it's simple. You whack away from it. You fling stuff in everywhere you can. You find yourself wondering if there's a way to check code in without putting your name on it. And then one day you realize that your life is a wreck. And then you hate this app. And you hate Ruby. And you hate Rails. And you hate your entire life. So this is, we all know that story. In the beginning, the app was a delight. You felt great because you were getting so much done. And that feeling, that deep feeling of satisfaction you got from your first Rails app was because of how efficient and productive it made you feel. We feel happy when we're doing our best work. And these feelings stand as a proxy for the state of our apps. And unfortunately for many apps, this good feeling peaks right around the time of the delivery of the first beta. And then goes downhill ever after. Things get worse and worse. You were fast, now you're slow. You were happy, now you're sad. You were cost effective, and now you're money pit. The app was amazing, and now it's just a mess. This does not mean that it's time to look for a new job. Amnesia won't help. Unless you change something, you'll end up hating every app you ever write. These applications are prisoners of their designs, and they've taken you hostage. You cannot outrun this problem. You have to do something different. You have to learn to understand the mess. And the problem with messes is, of course, that they're messy. They're hard to understand. Everything is tangled up together. They're like big tapestries made of many threads. The warp and the weft are woven tightly over and under, and they run in every direction. In the beginning, everything is idyllic, but as soon as you start making changes, that illusion gets shattered. Your app isn't a pastoral scene with little furry lambs. No, your app is trying to kill you. These are so woven together that you can't pull on any single thread without breaking the main thing. This is coupling. This coupling, the mess, is because of knowledge. Your app is made of objects, and you know things. They always know things about themselves, and sometimes they know things about others. And it's knowledge of others that weaves objects together. When an object knows something about it that's outside itself, that's a dependency. And we all know about dependencies, right? If something you depend on changes, you might be forced to change internally. You can't avoid dependencies. Objects have to collaborate. And collaboration requires that they know things about one another. However, there are many ways to arrange code to solve any problem, and you can easily arrange your dependencies so that things turn out badly. Controlling dependencies requires understanding the stability of the various bits of knowledge in your app. Everything, any object knows can be ranked along a continuum from really stable, completely stable to wildly unstable. And it turns out it doesn't really matter how stable any individual item is. It just needs to be more stable than the things that depend on it. Stability is relative, and things that seem wildly unstable from some points of view are perfectly reliable from others. And it's also true that sometimes you just don't know, you do not know how stable things are. You're confused. You can laugh. This lady is confused about why his parent put it in this. I can't explain. So you're confused about whether or not you can depend on things. And this is where object-oriented design gives us hope. Object-oriented design, OOD, is the ultimate dispenser of programming treats. Hope. It lets you write code that your future self will love, even in the face of confusion and instability. It knows how to separate the stable from the unstable, and it can show you how to depend on the first and hide the second. It gives you a way to manage the mess so that you can write apps that are efficient and fun forever. It changes everything. It lets you stop worrying and learn to love the mess. All right, that's the intro. Now we're going to start looking at code. If you're sitting over there, you should move over here. I'm just saying. All right, so I'm going to show you a really simple code example, and we're going to drive it to a couple of different factors. In the first example, I'm going to laboriously go through a very simple example and name all the parts so that we can talk about it. Then I'm going to introduce a change that's going to complicate the code. And then we're going to use the principles of object-oriented design to simplify the code and remove the dependencies. The examples are in 3 parts, and in part 3, a miracle occurs. So be ready for that. So this talk has an arc, and it is this. Concrete code is easy to understand and simple to write, but impossible to change. As you apply the principles of object-oriented design, you move your code along the continuum from very concrete to more abstract. More abstract code is easy to change, but harder to reason about when you first see it. And there is a place along that continuum where you want to land. We want changeable code that we can reason about and comprehend. And it is not the most concrete code, but it is also not the most abstract code. So this series of examples takes a concrete example, moves it, pushes it toward more abstraction along that continuum. Okay, so example number 1, label the knowledge. So imagine there's a game for racing bikes. Players have to buy parts, and one of the parts they can buy is a shock. And before buying that shock, players want to find out what it costs. Here's the code. Player can send shock costs to a game, and that will create a new instance of shock. Now, which sends cost to the shock. Now, assume that the inside of the cost method is this long, hairy, crazy, overcomplicated mess. But also assume this fact. Assume that nothing inside this method, you can make no change inside this method that would force a change outside of your app. Right? Make that assumption. And also assume there's no change out in your app that you can make that would force you to make a change inside this method. By that definition, this mess is completely self-contained. And because of that, it's as if it doesn't exist. Now, this is a special kind of a mess, and I'm going to give it a name. I'm going to call it an omega mess. Right? Omega messes are at the end of the line, and they have neither dependence nor dependencies. All possible messes fall into one of 2 categories. They are omega messes, or they are not. Right? So every other kind of mess is a more complicated mess, but this is a very specific kind of mess, and we're going to give it that name. And so now we've seen that code, and even though you haven't seen it, I didn't bother to write it. Assume it's Ames. Assume the cost method is Ames. The question right now is, what should we do? Should we do anything about that code? What are our moral and ethical obligations about this code that we have? And we're going to postpone that question for a minute, but that's the question we're trying to answer, all right? I just want to look at the problem a different way. Instead of looking at the code, instead of looking at the code, I'm going to draw a picture of the objects and the messages as they pass between them. This is a sequence diagram, and I love them. It's also UML, but it would be okay. Raise your hand if you have drawn a picture like this. If you have had occasion, so half the room, maybe a third of the room. Raise your picture if you've never seen a diagram like this before. Okay, some people, and it's perfect, right? That's a perfectly legitimate condition. All right, so I'm just going to explain. The boxes at the top represent objects. Classes and objects, so this could be an instance of a class or a class itself. the boxes repeated at the top and bottom. There's a vertical dashed line that connects those boxes together. When a message is sent, there's a solid horizontal line with the name of the method that's being invoked on top of it. This solid black triangle indicates that a game is receiving the shot toss method from a player. This vertical gray bar says that game is busy processing that method, and in return is the dashed line that's going back. I used web sequence diagrams to draw these pictures. I used this, every picture in the book, and this book was originally drawn with web sequence diagrams, and every picture in any talk I give is drawn with web sequence and diagrams, but I never do anything as formal in any other situation. I use sequence diagrams all the time. I just scribble on the whiteboard, erase them, or done. I never create permanent artifacts about them. So this sequence diagram represents the code we just saw. It's a visual representation of the knowledge and the dependencies in the code. I'm going to mark it up a little bit. I'll see if I got a way so you can see that. So I'm going to put knowledge on it. So errors are going to represent external knowledge, and this dashed line is going to represent internal knowledge. I'm also going to mark it up with stability, and that's going to look like a traffic light. Things that are really unstable are red, down to things that are pretty stable are green. And so what do we know here? Well, a game knows the name of the shot class. It knows that object responds to the new message. It knows that the thing it gets back from sending new to it knows the cost message. It knows, and it knows it can send costs to that. The result of that goes there. Okay, shot knows that it implements the cost message, and it knows how it does so. And so what you can see from this is that shot knows a bunch of things about itself. But game has a surprising number of dependencies, and they're all on an external object. This sequence diagram is a truer representation of what's going on. Then it's a true representation of the relative importance of things than is the code. Here, this big omega mess, which dominates in the code, is reduced to a little gray bar in the sequence diagram. From outside of shot, all you need to know is that you can invoke it by sending the cost message. And so here, this mess is hidden behind the message. This view of reality is incredibly deceiving. Here, we have this innate feeling that pounds of code ought to be related to importance. But in this situation, this set of code, which might be, let's assume it's many lines long, this is like a big, boisterous, drunken guy at a party surrounded by us introverts. When you walk into the room, it's easy to assume that he's the most important thing, but really all the interesting people are the folks like us who are sitting around and can't get a word in edgewise. It's not about the characters that are in the files that you typed in that live on disk. It's about the living, breathing, running objects as they exist in memory. It's about the message. Okay, so now that you've seen a little code, I'm going to just step up to 10,000 feet, and we're going to talk about what we just saw. This is a plot. It has, there's a space here in which I can put every bit of knowledge any object has. Things that are really stable to the left, more stable things are on the left, unstable things are on the right. The within my purpose and outside my purpose, that is, if this bit of knowledge should be the responsibility of the object that we're talking about. I'm going to talk about each quadrant represents a different thing, and knowing what quadrant a piece of knowledge is tells you what to do, what you should do with the code. Things that are within your purpose, that are within an object's purpose, that are incredibly stable, are part of its public API. Things that are unstable, that are part of its purpose, are part of its private API, private behavior. Anything below the line is a dependency. You should expose your public API. You should hide private behavior. In order to collaborate, objects have to know things about each other, but you should depend on only stable things, and you should depend on as few of them as possible. And if you know unstable things that are outside of your responsibility, you should move that stuff out of your class. Move it. All right. And so what do we have here? I'm going to take what we just put on a sequence diagram and just make a list of it. Shot knows the name, the cost method, and the calculation. And game depends on these three things. And I'm going to just wipe game off here. We're not going to talk about it anymore. There's enough meat in just these two things to get us through the rest of the talk. So the cost method, number one, the name of the method is a stable thing. It is Shock's responsibility to know the name of that method. It is incredibly stable. It belongs in the upper left-hand corner of this screen. It's part of its public API. The implementation, the internal implementation, is completely within Shock's responsibility, but it's incredibly unstable. So the code still belongs in this class, but we should hide it. Other people shouldn't have access to it. So we should expose the cost method and hide the cost calculation. And so there you go. I've been talking about this bit of code for 10 minutes. Right? So now we know all the things it knows and all the parts of it. And so I can take it, I want to return to the earlier question. Should we make a change here? Is it worthwhile to get in our editor and make any changes in this code? I'm going to ask you to assume a few more things. Our customer told me when they gave us this calculation that what they told us is probably not right. They know it's not right, but they wanted to do something to get the app out, and they're going to figure it out as they go on. Also, they already told us that they expect to have more shocks in the game. But they don't have them yet, but they're done. All right, so I have both of those pieces of information right now. What should I do? The way you decide is you ask yourself this question. What is the future cost of doing nothing now? You will always have better information later. You will never know less than you know right now. If it will not cost you money to do so, you should wait. Even if you know change is coming, wait on making that change right now. The most cost-effective strategy is very often to do nothing. And this is such a case. And it's because it's in a mega mess. It has no dependence and no dependencies. So you can leave it without consequence. Now, having said that, if this code were mine and I had 10 minutes, I would make a few changes before I walked away from it. I would inject this dependency because I am that way. And I would neaten up the mess. I would refactor out different bits and pieces of it and put them in small methods with intentional names. I would do those things before I left. You might not. I do these things almost without exception because doing the refactoring that neatens code is like buying a ticket in a lottery that's rigged in my favor. This pays off so often that my best strategy is to play every chance I get. I don't think of this as design. I'm not doing anything other than arranging the code that's in place to make it make better sense for me when I come back later. I'm not moving anything out of any other class, but it's often worthwhile to neaten. So I would neaten, but I would not do design. All right, and that's it. For now, we're just going to leave that code just like it is. And we're done with example 1. So let's make it more interesting. Let's change something. So let's imagine the game's a big success and the customer comes back to us and they tell us, oh, it is true. They want a bunch of different kinds of shock. And each different kind of shock has a different cost. And we assign that task, we assign that feature to some well-intentioned programmer. And they implement it. And here's how they do it. They collect a shock type from the user interface. They pass that into the game, they give them a shock cost, they forward that type to shock. And then over in shock, they take it, they put an arrow meter around type, and they pass it into they accept it in the initialize method, and then they write this case statement, which switches on type to get the right calculation. And so now I have 4 calculations in here, each of which is a huge mess. So what just happened? Well, let's look at the sequence diagram. It turns out that, like I told you, sequence diagrams were a better representation of what was going on in actual code. But there are programming sins that they're invisible in sequence diagrams, and this is one of them, this big case statement. You notice here, all I do is put a comment on the box. The sequence diagram looks almost identical to the old one, except for this parameter that's attached. You can't tell that there's a huge conditional in there. But there's a question we need to ask about this. The code that's in that method, is it still in a mega mess? Remember that omega messes have neither dependents nor dependencies, and that's what makes them safe to ignore. Is this still an omega mess? Well, okay, this used to be what Shock knew, but now it doesn't know one cost calculation, it knows 4. And it knows the symbols for 4 different type names. And it knows the mapping between the type name and the calculation it should get. These things are known to, but not owned by Shock. What will happen if the application adds another Shock type? What will happen if one of these calculations changes, or the mapping between a type and a calculation changes? Suddenly, there are many, many, many ways in which the outside app can change that forces me to come in here and make a change in this code. That case statement caused an explosion of dependencies. And so the cost method is no longer an omega mess, it's something else entirely, and I'm going to call that thing meta-knowledge. So meta-knowledge is knowledge about knowledge. Omega messes are hidden inside the pieces of the puzzle. And meta-knowledge is about how the puzzle is put together. And it's the domain of design. Object-oriented design can explain what just happened. It knows why that explosion of dependencies occurred, and there are many, many, many different ways to fix it. In example 3 in a minute, I'm going to show you just one of the many ways that you can solve this problem. But before we do that, let's jump back upstairs and plot this stuff. So we've already, cost method didn't change, so I'm just going to take that off. The 4 Shock cost calculations, they are, when Shock was calculating its own cost, it was clearly its own responsibility. When there was 1, it was its responsibility. But so knowing that 1 is okay, but now that there's 4, this is not about a shock. This is about a bunch of different shocks. This is unstable, and it's not Shock's responsibility. We should move this knowledge somewhere else. So how about the fact that it knows about 4 types? Well, again, it's the same problem as 3. The fact that there's 4 is not Shock's job. This should also be moved. And the mapping between the type and calculation, well, at least this is more stable. These mappings are probably more stable. But again, the fact that it's here, it means that it probably doesn't belong in Shock. And it's these new dependencies that make your code costly to change. This mapping used to be independent. It was absolutely independent, but now it's woven in the rest of your app. It's not only costly to change, but it's likely to change. Where you have 4ness, you will probably someday have 3ness or 5ness. Adding that case statement ruined a perfectly good omega mess. And it's really important because this problem is completely avoidable. You never have to take these dependencies. It's easy to arrange this code to avoid them. You just have to know a little bit about object-oriented design. And here's the guiding principle. I want to send a message rather than implement behavior. I don't want to know things. I just want to send a message to an object. All right, well that's great as a theory, but here the problem is I don't have another object. Shock is at the end of the line. It already knew how to calculate cost, and when whoever it was that made this change came in here, that was the only place where they could see to put the code. It seemed like the obvious place where this code ought to be. But that's the wrong point of view, and it's because it asks the wrong question. We acquired these dependencies because we ask, what object should know this? And we can remove them by asking, what message should I send? And then, once we find that message, if we have to, we'll just make a new object, and we'll send that message to it. And this brings us to example 3, composition, object-oriented composition. Now, I would explain this to you, but it is so much easier just to show you. I got this code, ugly, dependent-laden code that it can be forced to change for a whole bunch of reasons. I want to send a message rather than implement behavior. I don't want to know things, I just want to ask someone. So there's a repeating pattern here that you can see. Where every type gets its own calculation. And let's just look at the first one. I'm going to look at the original mess. I don't want to know this calculation, I want to send a message. Well, what message should we send? Well, how about repeat? All right, that sounds good. Where will I send it? Well, there's no, that's how we got in this mess. Well, let's just make something up. I like that, right? Some obliging object. Who is it? Well, how about that? I'm just going to make a new class. I'm going to call it shop class. I'm going to prefix it with the thing that used to be a symbol. I'm going to implement compute in it and move the original mess to it. Rearranging the code in this way gives me back my main mess in this one class. And now we have someone to ask, we can change the code. Now that we've hidden that mess, we can change this code to just send that message. Okay, well, and I can just do that for every one of these. I can just make a bunch of them, following the pattern of the class moving is doing a method extraction into this other class. And then when I'm done, I can just send all the messages. And so there you go, voila. Now cost is composed. And at this point in the talk, this is the miracle. And it feels really unsatisfying, doesn't it? You're like going, duh? Yeah, I know. And I think the reason people don't do this refactoring, that they can't see this refactoring, because they imagine that they're going to end up here. You imagine this is the endpoint. And it feels not very much, this is a legitimate question to ask this. Is this an improvement, or did I just complicate the code in the name of design? I used to be able to look right here and okay, it was an incredibly long method, at least I could tell what it did. And now I got all these other little classes that are someplace else that I can't see. Like I've broken this up, like what, is this an improvement at all? What does this accomplish? Well, the truth is some things did get better. Some things did get better. I used to know 4 shop cost calculations, and now I know the name of 4 classes. And I used to know 4 types, I still know that. I used to know what type got what calculation, and now I know what type is what class. There is good news here. The calculations have been re-isolated back into individual omega messes. You can change any individual cost calculation without the chance that you'll break all the rest of the code. You can test each one in isolation. So that is excellent news. This is an improvement. However, there's still plenty wrong with this code, right? The things that are wrong with this code is that many things about your app could change that would force you to make a change right here. Notice the pattern. Well, first of all, let's just say, I hate this code. I hate it. And it does not surprise me that no one wants to write code like this. We should not. But you have to go to this refactoring to find the next one. There's a pattern here. When symbol name, class name that starts with symbol, all right? That's like saying front shop cost is like saying food shop cost. We control the names, and because of that, we can do a very Rails-like thing and use a convention to manufacture the right class. It's really easy to build a string that contains the name of this class. Now I'm about to show you the next line of code you're not allowed to do, right? You can do this. If you have a class name in a string, you can invalid and turn it into the object. So all of those of you who really know Ruby hate me for even putting that up on the slide. But I think it's the easiest way to make the point. Really, Ruby, like classes in Ruby, there's like a whole list of them inside of Ruby, right? And if you have a string as a class name, you can just look the class up on this object const-get list. So you can do that. Or if you're a Rails programmer, which you obviously are because you're using the title on it, the Rails guys have changed the string base class to make strings know how to turn themselves into the class they represent, and that's this Constantize method. So if you can construct a string that contains the name of the class that you want, you can turn that string into the class and send new to it and then say compute. All of these work, but you don't use this one. And don't tweet that I told you you could. We can use this. This is a tiny little bit of metaprogramming. We can use it to manufacture a new class. Now I use the word manufacture quite deliberately. It's exactly right because this is a factory. Now I know that some of you got PTSD because you came from those languages where factories are really painful. And I have a little bit of sympathy, but really, I just want you to get over it, okay? You're here now. You made a good choice. You're in Ruby. Those days are gone. So, we love factories. We love them. Not only do we love factories, I want this word. It does not mean a bad thing. It means any bit of code that makes another object. And so I'm going to use it because it is the most efficient and parsimonious way to convey that idea. And I want you guys to use it too. It is okay to manufacture other objects. And when we do that, we use factories. And so here, now that I have this factory, I can remove the entire case statement. The cost method no longer needs to know the names of the 4 classes. It doesn't need to know the types, and it doesn't need to know what type gets what class. It just needs to know this convention. I can trade this code for this, which is a huge one. It's a huge one. There are no, this code is open for extension and closed for modification. I can delete a shop or add a new shop without changing a line of the code that I have. I can change any cost calculation without worrying that I'm going to have a negative effect on any other cost calculation. It's a huge win, and that is composition. Now, the official definition, the act of combining distinct parts into a complex whole, such that the whole becomes more than the sum of its parts. And here's what it feels like. This is a picture for those of you who are more visually oriented. This is what just happened. I used to have the cost method. I put 4 different calculations inside that method. We ripped them out, we wrapped them in classes, we decided on the interface, and we made every class implement the interface and the old method send it. When we do this, when you arrange code in this way, you make a bargain that the shop customers are going to obey that interface. When you do this, it's really easy to add a new one. You just make it obey that. You make it implement that message. The message defines the API of a duck type, which is the API of the role. Shop's cost method doesn't know or care about the class of the object to which it is sending this message. It just expects to be able to manufacture a collaborator that plays this role. Thinking of a collaborator as a kind of its role rather than a kind of its class changes everything. When you can manufacture the right kind of thing, it just plays the role that you expect. You can send a message to it and everything gets easier. Dependencies disappear and your application becomes a box of pluggable parts that are interchangeable like Legos. Design happens from the message sender's point of view. We don't send messages because we have objects. We have objects because we send messages. Object-oriented design is not in the business of dictating perfection. Its only request is that you remove the dependents and dependencies from all your sins, and you make them self-contained, and that you hide them behind stable interfaces. It shows you how to recognize what is meta-knowledge, and it tells you to use the principles of object-oriented design to organize the code to remove those dependencies. So that's OOD. If you know it, if you have these tools in your toolbox, you can do these things to arrange code and pick the right tool and the right code arrangement for the right situation. And I'm aware, okay, so I'm going to talk just for a minute, even though I'm on my clock up here and I know that. There's a big dispute, there's a big debate in our community right now about object-oriented programs, about whether or not the principles of object-oriented design are worth it. I submit to you that folks who say that design is not, that there's no point in learning these principles have written object-oriented code for so long that they inadvertently learned them themselves. And they might be calling them by different names. I believe this to be true because I did it myself. I'm vastly ignorant, and I spent a lot of time writing object-oriented code without having access to the academic literature about how to do so. I remember the day when I invented the null object pattern. I once thought that I had created the law of Denver. I was astonished, right? I was having a rant with somebody once and they were like, what are you talking about? I'm like, you know, I think the dot, 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 you should do that. And they were like, oh, you mean the law of Denver? And I was like, what? And they said, yeah, the law of Denver. And I'm like, it has a name? All right? Like, if you write enough object-oriented code, you're going to figure out what things hurt, and you're going to figure out a way to quit doing it. You can do that. I figured out Denver by writing crazy dependent-laden, insane code and paying a price. They say that, I used to do a lot of whiteboard typing, and we loved saying this. Good judgment comes from experience, and experience comes from bad judgment. And we were always trying to acquire experience by watching other people's bad judgments. Right? And you can do the same thing here. I have plenty of experience. I walked into the headwind for a long time, not realizing that there was a better way. And you might be different. But no matter how special you are, there is absolutely no need to suffer. We can learn from people who have gone before. Object-oriented design says stability is relative. You should notice it and depend on things that are more stable than you are. It says that what you want is more stable than what they do. What they do is messy and uncertain and changeable, but from the outside, from where I stand, it does not matter what's inside this house. If you arrange the code so that you cannot see the mess, it does not exist. We stand on the shoulders of giants. We truly do. We are so lucky to live in this age of information where the best thoughts of anyone are available to everyone. And I'm not saying that you have to be brilliant. I'm not saying that you're Isaac Newton, but we all have to start somewhere. And you can start out as an infant of design. And that's okay, because we can grow and change and learn and teach each other. It isn't always easy, and it's not always going to be fun. There's no guarantee that you're going to be happy every step of the way. But if you persevere, a time will come when your applications bring you nothing but joy. You will never outgrow the principles of design. If you learn them, you can use them and make them your own and write applications that you can love forever. Okay, now we're going to take questions, but first I get ahead of you. I've had my thinking period. So if you have a question, please. I'm serious. You think I'm serious? You think I'm serious? Something, huh? Questions? Yes.
So I've noticed for the past year and a half, just observing, there's been a trend in our community about talking about DCI specifically with respect to OOD. And my very naive understanding of it is instead of like having classes like that for the different shocks that you had, you're extending those at runtime. You're literally creating modules as new classes and extending them at runtime depending on what the object is, so you can only send the appropriate message and never create objects whose messages are never going to be given or passed around. So I was just wondering what your thoughts are. Sandy, you repeat the question?
Sorry, I'm sorry. The question was about DCI and where I thought about it and how I would use it in a situation like this. Is that characterized correctly?
What does DCI stand for?
DCI, sorry, that is an excellent question. Okay, so how should we arrange code? What are the big principles by which we should arrange code? Rails uses a pattern called MVC, Model View Controller, which you may be familiar with. That same guy, he has he's like Swedish or Norwegian. Okay, Danish. See, people know. Okay, so it might turn out that the MVC pattern isn't a big enough, permanent, it isn't the way we should fundamentally arrange code. So the same guy has this new idea. It's called data, context, and interactions. Right, so it's DCI. And it's fundamentally a different premise about how you would think about all the information you have in your app that would guide how you arrange the code. I think that there's something there. I've looked at a bunch of DCI code samples. I've had long conversations with Jim Gay, who wrote the DCI book, because he's from my neck of the woods, right? I'm down there. So and this is what I tell him every time I see him. I love the idea that I am not convinced because I have not seen code that is simpler than all of the alternatives. And so the DCI idea of, here's what they would do in DCI. If you haven't seen it before, you know how they're used to including a module in a class and decorating a whole class with that whole body of new behavior. But what DCI says is an individual instance of an object is going to play some role, and I will I will change an instance, a user instance once I create it, and make it be an admin. So I would mix in behavior to instances of objects. All of the code that I've seen that does that has a couple of flaws. One, it's very complicated looking to me. The other is that historically in Ruby, we've been unable to unmix them. So once you make that user object an admin, you can't get it back out. Or if you make a bank account, a depositing account instead of a withdrawing account, right, which would be something you might mix in. So if you think about all the different, you have a persistent object that has an active record model, which has huge chunks of behavior. And that behavior in your active record model often groups around business rules. Imagine if you could reduce your active record model to just its attributes and take those clumps of business rules and put them out in modules and then get an instance of that active record object and then turn it into something that understood the business rules for a specific case. That's what DCI does. Jim Day has just released a new library, and I forget the name of it, but I'm sure it's part of his GitHub repository, that purports to solve the problem of unmixing. All right? So he has written this library that lets you define a block and say, as an administrator, do. And it will magically mix in the behavior there. I think there might be something there. Here's the thing, like so many things, I would tell you this. I'm not using DCI right now, but me and those guys are smart, and they have good ideas that we can understand. We should steal them. Why not, right? And I don't want the code to be complicated. I'm willing to complicate my code to get that, but I'm paying attention to DCI, and it's a good thing to do that. Anything else? Really? Oh yeah, here we go. Come on.
So, when you spoke about the dependency between the game and the shock classes, but what about cross-cutting concerns in an app? Like for example, in the UI development or application development, you have settings which are globally pervasive across the app, or some preference level dialogue or dialogues in general which should be brought up anywhere from the app. So how do you deal with those kind of concerns?
So the question was about cross-cutting concerns. So here's what I would say. There's a difference between I am a and I behave like a. Right? I am a, my fundamental identity is a shock. I might behave like something in the user interface. And in Ruby, I generally will make a module for the behaves like a and mix it in. Now, DCI can help you there if you want to use DCI techniques. But I think of objects more so, like I've been thinking about this really hard for a couple of years because they made me, right? They made me write that book, so I did it day after day after day. And I had one sort of transitional, there's been one permanent transition in my thinking about objects that happened over that period of time. And it's about the importance of thinking about an object as a player of its role, as opposed to an instance of its class. And so I'm very serious about being very clear about what the API or cross-cutting concern is, and giving that API somehow to all the objects that play that role, and making them obey, making them honor the contract and play that role honestly. In Ruby, there's a bunch of ways to do it. You can use DCI, you can make modules, you can do an inheritance hierarchy. You can do it any way you want. You can just implement the methods in all the classes that do it. But if you want to, I think your question, it's probably a truer characterization of the question you asked me is probably how do you implement shared behavior in cross-cutting concerns? And
also, how do you pass it down?
And how do you
pass it across the application?
There's so many different ways. Let's talk about that when we're done, right? But it's an interesting question, and yes, here. Then I'll go on a long tangent about it that'll bore everybody else in your sense. So if you're interested in that question, come to the front and we'll talk about it when we're done. Okay, so somebody here had a question?
Yeah. Let's see if I can phrase this correctly. So I noticed that you used, in the cost method, you created service objects to, like the front shop cost dot fed, which I understand is a service object.
Tell me more about that.
It's just something I've been reading about a lot lately.
Service object
element is a class that you would create, and it would have a single public API method that would do one thing, like a business, and sort of like calculating a cost. Do you prefer doing that compared to, say, putting the factory in the new method of shop to return some classes?
The question was, he was using the word service object to describe the front shop, the shop costers that I created. And he asked me about that, and he also asked me about where the factory goes that makes a new one of those things. I'll answer the second question first, okay? So where does the factory go? In the talk, it goes right in the method that I'm calling it from. In real life, it probably doesn't, right? In real life, you probably want a different object. I tend to put factories on the class side, someplace over in the hierarchy of the kind of thing I'm making. Like, so if there's a shock inheritance hierarchy, or if there's a coster inheritance hierarchy, where there's a coster superclass and a bunch of subclasses, I would probably put the factory on the class side of the parent class. If you don't have an inheritance hierarchy, like where's the law? I'm just looking for a place to put it where people will know where to look for it. And so sometimes I have to make up a new whole class to be that factory. I tend not to do what I did in this example, which is put it right in the method that's trying to give one. But in an example that's simple, if I had a case that's simple, I might just put it right there. I don't think of so does that answer your question? Well, can I say one more thing about that? Like in the examples I used in the lunchtime talk today, and then probably in some of the examples here, I'm doing things in the initialized methods. And that is the kiss of death for testing, right? You don't really want to do a bunch of setup of collaborators in your initialized methods, because it's very hard then to do a different thing when you're constructing the tests. And so many things, the principle of composition holds, even though the details are probably slightly different than what you would get in these examples. As far as service objects go, like I write a ton of objects that sit in the middle between the Rails framework, PORO objects that I use to do things. I actually had occasion to refer to Brian Hopkins' blog post about 7 ways that you can put your bag in models the other day. And he uses service for, because he had a very specific definition of service, which I thought was useful.
Yeah, well, the one that I was using in that post was just an object that encapsulates a single business sort of action. So something like, order processor for a checkout.
And so that, like, there's the guy who made up the guy who first popularized the idea of service objects, Eric Evans, in the domain-driven design book. Like, his idea of a service is one thing. We tend to use services that encompass a simple procedure, tend to be named with verbs, and to maybe hook up to an active record, a route, a RESTful method. These things, I don't really think of them as service objects, and I think, why would I not? I think of them not as service objects just because I think of most things as being plain old Ruby objects. So they just seem like things to me. Like, I think of a service object as something, here's the definition I'll give you. I'm going to make this up on the fly. I think of a service object as something that contains the business rules that control the collaboration between two persistent models. And this didn't do that. This is just some rules. And so it's just a thing to me. Whereas a service object, I have something more stringent definition for that. I have very often my controllers invoke service objects because I just want the controllers to know the name of one class. And so if the controller needs to do something that involves a bunch of different active record models that the Rails app, I will make a service object to handle that collaboration and have the controller know that thing. And I call that a service object. It might be named with a noun, in which case it's used in a bunch of different incoming messages. If it's named with a verb, it tends to be more like this procedure, and it goes with that one. With that specific edit or show or whatever you're running. Can we talk more about that later? I'll see if I can do one. Yes?
So speaking of the controllers and really only know one class, I know that you had came out with some development rules.
Oh, they're going to chase me around forever.
And so can you elaborate a little bit more on why you think controllers should only have access to one class?
Yes, I can. I'm so glad you asked. This was not a plan. So think about this.
Repeat the question, Sam.
Oh, I'm so sorry. I suck at that, don't I? So she wanted, okay, I suggested some rules for programming, very stringent, very specific rules for how to write object-oriented code. And on a Ruby Rogues episode that I was on, and she asked me to elaborate on those rules. First, I'm going to go on like 6 digressions. Okay, I'll try to be brief. One is that it was astonishing to me what you may not have heard of it, but since I was on the receiving end of it, I thought of it as being an absolute internet fervor started based on these rules. So first, let me tell you what the rules are. Your class can be 100 lines long. No more than 100 lines long. Your methods can be no more than 5 lines long. I'm kind of making this up. These are approximately right. You can take no more than 4 parameters, and you can't cheat by passing a big hash. The incoming request, your RESTful method in your controller can only know the name of one object to instantiate to do with whatever it's doing. And even though I didn't say this very well in the row, so this has been misquoted everywhere, it can know the name of another class to handle presentation. It can only pass one instance variable back to the views. All right, so your class can only be this long, your methods can only be this long, you can only take this many arguments. The controllers can know the name of one class to deal with persistence, and I'll give you another class name for a presenter. And you can only set one instance variable for your views to talk to.
Can the instance variable be a big hash?
Stop that. Stop that. Okay, now let me give you a context, right? I was consulting in a business where they had 1,000-line controllers. They were setting so many instance variables for their views that they gave up and just set them all every time. Because it broke so much. Like, I didn't know what it would take. Stuff would blow up and it would be a mystery to them, all right? And so these rules were intended to be an antidote for overt excess, right? The other side of the teeter-totter. However, they're not bad rules. They're not bad rules. The interesting thing to me about these rules is that it was like a bomb went off. Like, people were writing blog posts about it. Like, it circled the planet like 4 times. Like, people were joking to me. I was like, whoa, like that. Let's have a little common sense here. And people were saying, oh, they're... Like, people are calling them commandments, and then suggesting that I could chisel them in their iPads. Right? The thing I took away from it was not so much about the rules, but about our apparent desperation to have them. That was very interesting to me. Why? Why do we care enough to have that level of animation in the discourse about a set of rules? All right, so I think that is a very useful question for our community. How is it that we have left people so desperate for rules? I think the rules in general, I write those rules all the time, but they're good rules. They're heuristics. Like, here's what I would say: if you're a novice, obey those rules. If you don't know better, they will keep you out of trouble until you learn something. Right? Once you grow up, the 6th rule I gave them was you can break any rule that you can convince your pair that it's a good idea. Right? You have to get permission from some other adult human being that it's okay to do this. All right. All rules are meant to be written. Why do we have rules? And so we can write changeable, cost-effective code. And so we're trying to do that. I write these rules all the time, but I kind of follow them. And so now I'm going to go back, really, I think, to the point of your question. Rails apps. What is a Rails app? How did I derive these rules? What is a Rails app? What is the pattern in a Rails app? There's a mapping between a controller action and a row and a table in the database. And in the blog post app that we all saw, the blog at 15 minutes, what did they do? The controller knew a single class. And it got an instance that, as I was saying, find.id. And it created a single instance variable and passed it back to the user. This is the pattern of Rails, and it works. If you have a Rails app, you should do exactly that. If, however, you have an application that uses Rails, which, believe me, if you have a monorail that's killing you now, you have an application that uses Rails, not a Rails app. Right? If you have an application that uses Rails, what happens is you look at those people, you look at controllers and they're 1,000 lines long, and every controller action knows the names of 10 or 15 classes. And they set a whole bunch of instance variables and pass it back to the user. I think we should be following the Rails pattern, even when we have apps that use Rails and not Rails apps. And the way to do that is to drive the edges of the framework apart and put your own stuff in the middle. And that means creating a service object that knows how to have the business rules of the collaboration between active record objects, and making a presenter to wrap around that so you can pass one instance variable back to the user. I'm not saying don't use Rails. I'm saying do what Rails meant you to do. But Rails does not mean for you to put all your code in a framework. It means for you to it wants you to follow the conventions of Rails and write your own objects if you have to. When you drive the edges of the framework apart and put your logic in the middle, you can test it, and you can move, like someday, okay, I'm older than you are, listen to me. Smalltalk, I've gone from Smalltalk to Java to Ruby. I'm on my 3rd framework for some of the data that we use at Duke University. Another framework will come, and you're gonna wish that you could get to your business logic and easily port it. That day will happen. If you're lucky, right? If you're lucky. you will see that day, and most of you will. It will be a terrible accident if you're not alive to see that day, because it will not be long. So I love the Rails patterns, but I want to use the Rails patterns, and that forces me to write business objects. So that's where the rules came from. Rand, sorry, can't help myself. Anything else?
So about more rules, what do you think about this whole AntiIF campaign?
I think that the principles of object-oriented design are such that you can write code without ever writing a condition. That is a true statement. Right? And well, we get it here. That case statement's a conditional, right? And I submit to you that it's a really good idea to do what happened here today. I like the no logic pattern. I hate using case statements around that. Like I'll make little objects that can stand in for a thing that's empty. However, is it cheaper sometimes to just put a simple if statement in? Well, yeah. Like, pay attention. Like, as long as you know the rule and you know that you could avoid it, and like write that code in bytecode climate, and if you never see that class on the churn chart, you're good to go.
So, Sammy, what's your rule on metaprogramming versus conditionals? Because both examples you've given earlier today say replace conditionals with metaprogramming.
Okay, I mean, here's the deal. Like all of it, so I told you at the beginning of the talk that ARC was from more concrete to more abstract. And often that means taking a law procedure and turning it into a bunch of little objects. And so the problem becomes one of getting an instance of the object that does the right thing, right? That's what all of the talk, the talk I gave today at lunchtime in this talk, turn the problem of design into making a bunch of small objects, and then you have to get the right one because you can trust it to do the thing that it's going to do. Very often that takes a factory, and very often factories involve a little bit of metaprogramming. Now you can take, it is perfectly acceptable if there's not like the case statement that's switched on type to figure out the name of the class, like you can just put that in the factory. But it's often cheaper to do a little bit of metaprogramming in that carefully curated, very managed environment to generate that. Metaprogramming is such a two-edged sword. I love saying this. If I'm the queen, I know I'm not the queen, but if I am the queen and I give dispensation, I would allow people to use metaprogramming, but you better write code that I can understand. Like, you better not make me hate you later when I have to debug that. Like, it better not break, it better have good test coverage, and it better be very clear. Like, I don't want to take that power out of your hands, but you know how when you're refactoring code and you're cleaning it up, you're taking stuff out, you're drying it out, you often get to a point where you could do one more refactoring. You could do one more refactoring. And that refactoring, there's a bit of duplication in your code that you can remove with metaprogramming at that point. It is often a good idea to stop and not do it. Because the cost of that complexity is going to be higher than whatever it saves you. In this case, I knew I was going to have more shocks. And so I felt it justified being able to manufacture a new thing, give it a new type. But very often, if you're not going to have more of that thing, you should just write it down and leave it. And so I love metaprogramming, but I'm often quite confused by other people's metaprogramming. And if all of the downhill consequences of any bit of metaprogramming accrued back to the person who wrote it, I would be fine with it. You can use it in any situation, but if other people are going to have to look at your code, the standard of proof is very high before you're allowed to do that stuff. We
You
done?
try and cover all those edge cases with unit tests?
I test the margins and then the middle. There's a very interesting talk I just watched by Michael Feathers from last year's Software Craftsman of North America, the SDNA, where he advocates deleting some tests, even tests that are running in work. And I found that shocking and like a titillating idea. And so I don't have tests for everything. If you're interested in the idea of whether or not you're safe without a complete test coverage suite, that Michael Feathers SDNA 2012, it was in last fall. And so I tend to do that thing where, like, lots of things, like I don't write tests for app readers. And someone asked me once, like, do you test that your app readers work, like the public app? And I was like, well, they always work. Like, they never break. Like, it doesn't seem worthwhile. It doesn't seem worth the money to write that test. even though I don't have coverage, I would say. So I think if things start to cost, I would write more tests. As soon as it starts costing me money, I write more tests.
For each of the factory.
No, I would put food in. I would make sure I could manufacture a thing based on.
Food shop.
Yeah, food shop. I would do the generic case and have that be both the documentation and the test. Like, I don't know, because I don't want to be tied to what's coming in. I mean, that's my goal, right? To be untied and to tell the story in the test that says, here's what it does. You give it a symbol name and it makes a class out of that symbol. Okay, I'm gonna keep talking. Okay, you done? Thank you. Oh, beat it, do that.
See this? Will be better.
Do it. It's even better.
So if you think that Sandy is a good person to listen to about this type of thing, she has a book, and it's a great book. It's called Practical Object-Oriented Design in Ruby. How do you pronounce the Hooter? Hooter. Hooter book. I was just checking. You should buy it. It's very much about this kind of stuff. So it's the book that I recommend to everybody when people come to me and say, where can I learn more about this? This is the best answer that I've got. So, Sandy's book.
Give it away.
Oh, give it away. How do I give it away?
First question, I usually do.
We do like a trivia question?
Yeah, whatever. I'm not making it up. I'm done. It's on you, bud.
Who's got an object-oriented design-related trivia question that I can ask?
What's the first object-oriented language?
What's
What would you say?
Yeah, wait. But it can't be subjective.
What is solid-state?
Yeah, okay. First person to list off correctly the names of all 5 solid principles in order. Raise your hand if you want to compete. Seriously? Come on, someone can do it. It's a new mind. Solid. 5 principles.
If you're willing to.
Yeah, go for it.
Simple responsibility, open for flexibility, closed for modification.
Give you that.
L is list off.
Yep.
I is interface segregation.
Yep.
E is dependency injection.
Inversion. Close enough. So that concludes our program for today. Feel free to hang out and have another beer and chat with yourselves, chat with Sandy, and then eventually we will make our way to a local drinking establishment. So thanks for coming out. We'll see you next month or at the next class.